Yeah, let's go. What's electrical power surge? Electrical power surge. All right, Joseph. Electrical power surge is a sudden, unwanted, and short duration increase in voltage in an electrical circuit. Electrical power surge is transient. Whenever I say yes, transient, only a brief period. Hence, it is also called transient overvoltage because it occurs only for a short period. The surge or transient overvoltage only lasts for a few microseconds. A microsecond is also called millions of a second. That is 1/1 million. Um, in physics, after the standard unit, you have milli, micro, nano, and the like. So micro is what 1/1 million. Note that a blink of an eye is thousands of times longer than a typical surge. The figure below shows a surge that occurs in less than 1/60, that's 0.016 seconds. This is a 60 Hz frequency. Yes, I'm recording it. This is 60 Hz frequency. A 60 Hz means you have 60 waves in 1 second. A surge will occur in 1/60 seconds. So this is a power surge. Just occur for a very big period, 0.016 seconds. In electrical and electrons, the time you use the electrical electrons, they are quite small, less than seconds, microseconds, nanoseconds. So they are not like a woman that will use second. Most of us we use second as humans, but that is what you understand. But when you get to electrical electron, you talk about milliseconds, microseconds, nanoseconds. So a surge occurs in less than a second, just a 1/1 million of a second. So those over voltage, that is what we call a power surge. The surge can connect thousands of volts and thousands of amps. If you know the common causes of electrical surge, you have lightning strike, both direct and indirect lightning strike. They are causes electrical surges. We have power outage. Whenever there's power outage and you want the system back, there'll be a power surge. When the system is just starting. That is why it's advisable that when you want to on a generator, you first switch off all your appliances. Then after the generator have started, you now on the appliances back. If you just switch on the generator while all the appliances are on, there will be surges because the voltage will first move to the peak before going back to normal. So power surge, whenever power outage occurs, there will be a voltage surge. And when the power is switched on, there will be voltage surge. But when the power is switched off, there will be what? There will be a current surge. The current is try to what? Continue flowing before it stops. We also have trip circuit breaker. Whenever a circuit breaker trips, it will cause power surge. We also have short circuits, and we also have poor wiring installation. When installation is not done well, it can lead to different surges. It also can cause damage to electrical and electronic equipment, causes electrical fire, data loss in digital devices, or severe property damage. The effect of a surge can result in either instant failure or damage to the equipment, only evident over a long period of time. A power surge may only last in milliseconds, but it is one of the most severe and common dangers to electrical equipment. Business Week estimate that power surge costs American business over 26 billion a year in lost time, equipment repair and replacement costs. That is by ENC Insurance.com. That is an insurance company in the US. For business and industry, the following are some of the effects of power surge: high facility maintenance costs, equipment failure, long-term system degradation, process disruption, data loss or corruption, and costly downtime. And when you are dealing with residential system, you might not know the importance of surge protection. When you get to the industry, they don't play with power surge. A protection against electrical surge. A surge protective or protection device, SPD, is normally called a surge protective device, but some call it surge protection device. Also called transient voltage surge suppressor, TVSS, is a device designed to protect electrical and electronic equipment from power surges or transient overvoltage. An SPD is used to suppress transient overvoltage and transient overcurrent in a circuit. It is used to protect electrical and electronic equipment. Equipment and sensitive electronic circuitry are very vulnerable. Equipment with sensitive electronic circuitry are very vulnerable to damages by transient overvoltage. We have electrical equipment and we have electronics equipment. Electronics equipment are the ones that are most vulnerable to what? To damages by transient overvoltage. Hence, SPD is used to protect sensitive electronic equipment such as computers, televisions, telephones, and safety equipment like fire detection equipment, CCTV cameras, emergency lightings, and others. SPD is also used to protect solar system and other electrical installation like socket and display board from transient overvoltage. Aside from voltage surge, we also have a voltage spike. Voltage surge and voltage spike are both overvoltages that can occur in an electrical system, but they differ in their characteristics and cause. A voltage spike is a sudden, brief increase in voltage that lasts for a very short duration, typically less than 1 microsecond. The magnitude can be several times higher than the normal operating voltage and often caused by lightning strike. When you have voltage spike, it's often caused by lightning strike. It's higher, its magnitude is higher than the voltage surge, but it occurs for a short duration of time than voltage surge. The voltage on the other hand have less voltage than voltage spike, usually 10% to 35% above the normal operating voltage. But that's a longer duration, generally lasting from milliseconds to some seconds. Voltage surge can originate internally by the switching of electrical loads, generator switching, circuit breakers, tripping, and sudden change in load. It can also originate externally caused by power distribution network or switching of heavy loads by neighbors on the same network. Sometimes you see that when your neighbor is switch on a high equipment, maybe a water pump, you see that your lights will blink for some time. So that surge is caused by your neighbor because you switch on a high electrical equipment. Voltage surge is common than voltage spike, yes. Voltage surge account for more than 80% of transient over voltage. Since voltage surge is the most common, both voltage surge and voltage spike are often referred to as voltage surge. Voltage spike and voltage surge can potentially damage electrical and electronic equipment. An SPD can protect electrical and electronic equipment from voltage spike and voltage surge. Surge protective device, SPD working principle. Device that is used to protect against voltage surge is called SPD. I've mentioned that before. What is an SPD? According to IEC 61643, that International Electrotechnical Commission 61643 2011, terms and definition. A surge protective device, SPD, is a device that contains at least one non-linear component that is intended to limit surge voltages and divert surge currents. The working principle of SPD is based on limiting voltage and diverting currents. When the voltage exceeds a safe threshold, the non-linear component SPD quickly reduces its resistance to divert excess current to the ground and limit the voltage to the equipment, thus protecting the equipment. This is transient over voltage. This is the normal voltage the equipment needs. So this is an SPD, and this is the equipment you want to protect. So whenever the transient over voltage occur, the SPD will start conducting and divert excess currents that can damage this equipment to the ground. Why the word? To limit the voltage to the voltage that the equipment needs. It diverts transient current to the ground and limits voltage to the equipment. That is the working principle of a SPD. This is it, lightning current. You see, it will divert it to the ground and to protect equipment when you have SPD installed, sensitive loads. This is type 3 SPD. We speak about the type later. So it protects sensitive load like computers, laptop, printers, and the likes. During normal operation, in the absence of surges, the SPD have no influence on the system where it is installed. It acts as an open circuit and maintains the isolation between the earth conductor and the active conductors. That is live and neutral for AC, positive and negative for wires for DC. This is it for normal current and voltage. This is SPD. SPD is not working here. It doesn't have any function with the system. To just be there during normal operation. Normal current and voltage will be flowing. But when current with voltage exceeding MCOV, that is the maximum continuous operating voltage of the SPD occurs, the SPD will start conducting and it will conduct excess current to the ground and allow the required voltage to pass through. So when a voltage surge occurs, the SPD reduces its resistance within a few nanoseconds, limit the over voltage to an acceptable value, and divert the excess current to the ground through the acting conductor, thus preventing the equipment connected downstream. The maximum voltage an AC can withstand without beginning to conduct is called maximum continuous operating voltage, MCOV, or represented by UC. MCOV is usually 10% to 25% higher than normal voltage. Once the voltage exceeds the MCOV of the SPD will start conducting. Let's assume that the normal voltage required by the equipment is by the load is around 230 volts. So at 230 volts, SPD will not conduct. 240 volts, SPD will not conduct. But if the load is now 10% to 25% higher, if the voltage is now 10% to 25% higher than what the load requires, SPD will start conducting current to the ground. Hence, the SPD behaves like a closed circuit when voltage surge occurs. Once the surge has stopped, the SPD will return to its original impedance and return to the open circuit condition. I'm noticing something to be corrected in the slide. Based on this working principle, an SPD can be viewed as a normally open relay. Some of you know what a relay is. You have two types of normally open relay and normally closed relay. So an SPD can be viewed as a normally open relay, which is always open during normal operation, during normal condition. It will be open in the absence of surge, and then closes during abnormal condition when surges occurs. The internal non-linear component of ISP can be avalanche, breakdown, diode, metal, oscillator, varistor, gas. These are the non-linear equipments. We have linear equipment. A resistor, a wire is a linear equipment. For those equipments, they work linearly. That is when those linear equipment, they obey Ohm's law. For those linear equipment, V is equal to IR. They are used for those linear equipment. When the voltage is high, when the current is high, resistance increases. That is Ohm's law. But all these non-linear equipment, they don't obey Ohm's law. So whenever the voltage is high, that is when their resistance reduces. So they are opposites of Ohm's law. When they are discussing Ohm's law, say ohmic conductors and non-ohmic conductors. Ohmic conductors are conductors that obeys Ohm's law. When the current is high, the voltage, when the voltage is high, the current is high because V is equal to IR. But non-ohmic conductor is different. So when V is high, that's when the resistance will reduce. So there are non-linear components, and these are the four common non-linear components that are used for SPD. Note that a surge protective device is different from a voltage protector. SPD protects appliances from transient overvoltage, which occurs for a very brief period of time. Voltage protectors protect appliances from voltage fluctuations, overvoltage, and undervoltage, which mainly originate from the power supply source. It can be grid, generator, inverters, etc. Voltage protector operates for a long duration, which can span from minutes to hours and days, while SPD operates for a very short period of time, mostly milliseconds or a few seconds. That is for SPD. These are the image of SPD. These are SPD line, and this is live and neutral SPD. That is single phase. This one is three phase, L1, L2, L3. This is SPD for transient overvoltage protection. It's not for a continuous voltage. Below are some voltage protectors. These are voltage protection. They operate against voltage fluctuation, over voltage, and under voltage for a long duration. So either SPD is only for over voltage, transient over voltage that occur for seconds or for a second or microseconds. But for long duration over voltage or under voltage, you need a voltage protector. And the common ones are what's called this one? Stabilizer, AVR, automatic voltage regulator, a type of voltage protector. We also have voltage switcher, AVS, and these are the voltage monitoring relays. So they are different from SPD. They are not SPD. These ones, they can protect an equipment from under voltage. SPD cannot protect equipment from under voltage or voltage fluctuation. Kayode is after this thing that will take question. I'm not taking question now because we still have a lot to cover. Type of SPD. SPD are classified into type 1, type 2, and type 3. We have type 1 SPD. This is installed at the service center of my electrical system. It's designed to withstand high energy surges, protecting severe transient events for equipment and circuit within the electrical system. A lighting protection system is located in the building or location. It is used when a lighting protection system is located in the building or location. So that's when we use type 1 SPD. That's why we use type 1 SPD. When a lighting protection, we spoke about lighting protection system too. When a lighting protection system is in a location or building, that is when we use type 1 SPD. Then we have type 2 SPD, that is the most common. This is installed downstream from type 1 or at the distribution panel. It offers protection against residual surges and lower energy transients, working in combination with type 1 surge protective devices. Note that we have type 1 and type 2. Note that the type 1 and type 2 can be combined in a single SPD, and this is called type 1 and 2 SPD. It's also installed in the distribution panel. So instead of using type 1 and type 2 separately, some manufacturers of SPD, they manufacture both type 1 and type 2 SPD. So to protect against lightning, that is direct lightning, and also protect against electrical surge. You have type 3 SPD. These are installed at the point of use near or within sensitive equipment, providing protection against low energy surges that's relatively minor but enough to damage specific equipment. We also have type 4 SPD, which is not commonly used. It's majorly used in the steel industry to provide protection to servo motors, PLC, and other devices used in industrial application. Sometimes you're hearing type 4 SPD, but it's not common. The graph below shows the fine protection architecture and installation location for type 1, type 2, and type 3 SPD. So this is type 1 SPD. It is located here. It has the ability to divert over 90% of the energy that is coming from the what? Direct lighting or other sources, majorly direct lighting sources. Then you have the sub-distribution board where we have the type 2 installed. This is usually installed in the distribution board. It will divert over 90% of the overvoltage surges that is coming. Then you have the last one, fine protection enclosure. That is for sensitive equipment, type 2, maybe for computers, laptop, and majorly for data protection, data equipment, electronics. So we use type 3 SPD2. So these are the discharge capacity of those SPD. Type 1 have under 90% discharge capacity. Type 2 has over 90% diverse